Yep, I hear you. All right, thank you. And I'm assuming the audience can hear me as well then. I can see the audience. You can nod if. Yeah, let me do that. Hi everyone. Has Ejvind given a quick introduction, or should I? Should I just start presentation? Great. Let me do that. Let me see if I can figure out the sharing first. Moment of truth. So, do you see a screen now? Data mesh at Vestas. Great. So far, so good. So, hi everyone. My name is Ulrik. I'm a lead data engineer at Vestas. I work in the digital solutions team, where we are implementing a data mesh. I'll get back to later what is it actually we are doing as part of that and what I'm doing. So let's start first. What is Vestas? If there are someone here who don't know what Vestas is a company that designs, produces, and services wind turbines. Really big machines. We have more than 55,000 turbines that we have installed and are servicing worldwide. Now, in order to support being able to keep 55,000 turbines online and producing power, we need to be in control of the data that we are producing. So, as part of an ongoing journey, we have begun implementing a data mesh to drive our data solutions in Vestas. We come from a scenario where we have different legacy on-prem solutions that we are now trying to modernize and figure out how we want to deal with in a better way. So in the data mesh, we want to have different data domains that will output different data products, centered, for example, around data we get from our turbines to provide turbine performance metrics, centered around the service supply chain that can give us information about what are we doing in maintenance, and then we want to be able to open up for innovation of doing a lot of different data products for solving different business problems on top of that. So this is an ongoing journey we are on. We are powering this with the Vestas data platform. The Vestas data platform is self-service tooling that we can pick up in order to realize some of these data products. As part of the data platform offerings, we have streaming capabilities, we have storage capabilities, we have compute platforms, and then we have DBT as a batch transform framework, among others. So as a data product producer, I can pick up one of these tools, and then I can define a data set that I will now be exposing into the ecosystem. So now let's go into the topics for the presentation today. So first off, I want to talk about how have we been approaching collaboration across these technologies? How do we enable seamless collaboration in a multi-platform mesh setup? Then I want to jump into the whole, how do we scale this mesh across different teams? How do we try to organize around that? So let's take the first challenge here. How do we collaborate across technologies? And in order to do that, we will need to go on a journey. The journey brings us to the Coalesce conference last year in October, where we had a session about how we have used Iceberg to implement a solution around how we share data between data products. So this is a bit of a recap from that session. So presenting on that session, it was me, it was William, my colleague, who was not able to be here today, and then Anders from DVT. So we got in touch with Anders, I think around August last year, that we were starting to explore this solution space around, hey, we have these different data products, and we want them to be able to collaborate to share data between them together. How can we approach that? And we ended up doing a collaboration that ended up in two things. One, a live solution that we have running in our production setup now, and two, the whole session here and that I'm about to show you. So if we take that challenge, what is it we have as an issue? We have these different technologies inside of our data landscape. What is the core challenge there? That is that we end up having technology blocking collaboration instead of enabling it. So how have we tried to get around that? Well, we started out from a scenario where we basically had no collaboration. So we had each project was running on their own and implementing logic on top of raw data from scratch. Then we tried to see, can we do that a bit better by sharing some common logic through a central DBT package that then showed us how can we then implement some of these standard transforms. That scaled a bit, but not enough. And then last year, the news around Iceberg was picking up. So Iceberg was basically the technology trigger that we began exploring. Can we use Iceberg to alleviate some of these pains? So Iceberg, the quick recap of Iceberg is that it's a technology that is rapidly being adopted, both inside of DBT and across the whole data ecosystem. What does it do? It enables our data platforms to decouple and still, and allows the data to be interoperable so we can use it from different platforms. And then it's still emerging. Everything is still maturing, at least it was half a year ago. So a lot of excitement was around how to do this. So at that point in time, there were already quite a wide support of Iceberg as a tool across different data compute platforms. So let's go a little bit deeper. What is Iceberg actually? So what you're looking at here is basically an Iceberg table. So what is it? It is basically just a bunch of files in a data lake or in object storage. So this table here, Iceberg table, has two folders here. It's data and it's metadata. So inside of the data folder, you will have some Parquet files, which will hold the compressed actual data. And then inside of the metadata, you will have information like this, that then is the abstraction on top of the raw data. So it allows us to implement, for example, transactions on top of the raw data. So I don't need to know all of these details, luckily, because our different data platforms, they abstract it away from. So if we just open quickly a little bit, what is a cloud data warehouse actually? What does it contain? It contains a number of different abstractions inside of it. What do they do? Well, we have the query engine. What does that do? That executes queries. That is where the actual work is happening. What does that do? It talks to the catalog. What does the catalog do? It knows where the tables are and what they consist of. What does that do? It talks to the table format. So this is where we get into the Iceberg metadata specification. And then that then talks to the Parquet file. So we know where is the actual physical data stored, how is it compressed, how can that be understood. And then the final abstraction is then the object storage, where the actual data is hosted. Now, when we're talking about Iceberg in this context here, and what we're talking about is this decoupling here to say Iceberg can provide these boxes down here. So Iceberg works as an abstraction layer where we can store our data. We can have our compute engine interacting with the data, with the catalog. Yeah, that's all I'll talk about Iceberg, how it works under the hood for now. So now let's jump into what we implemented together with dbt. So what we implemented was a first take on how can we do a cross-platform dbt mesh. So what is that? Well, basically, what we have in dbt is we have a data product being produced in Spark, and we have another data product that would like to consume that data in Snowflake. So basically what we need to do is we need to enable this arrow here. How can I serve data from one dbt project into another? Now, dbt, what do we call it? The technology that we are using here from dbt is cross-project workflows. So I have a dbt project up here that contains a number of models and then exposes some interfaces, some tables as interfaces that I can consume from another project over here that can then just use the ref function to say, I would like to consume the table you expose over here. So this is managed by dbt Cloud, and that is part of the dbt mesh setup that has a framework for how you bundle this. What is new around this is the whole how to do this across data platforms. So the way we achieved this was that first, when we are producing data, what is happening is that our dbt project is executing some queries in a Spark cluster. That is then materializing the data in an Iceberg catalog, and then actually the Iceberg tables are stored in storage. What we then do is that this storage is then made available to Snowflake through an external volume, and then the Snowflake database gets to know about these tables from the Iceberg catalog. That is done using the REST catalog integration that was made public preview in August last year. That allows Snowflake to query an Iceberg REST API and then get information about the table that it has made available. And then finally, now that we know that the table exists, we are able to then execute a query against that in our Snowflake warehouse and then produce the output tables in our dbt project. So that is essentially the under the hood of what did it take to get this small arrow up here to work. Now, the way that looks in our production setup right now is that the producer data product takes responsibility here for publishing information to Snowflake. We had some design sessions with the dbt team around this. Should the responsibility for this actually live on the consumer side here? Should the consumer be responsible for registering these tables and knowing that they exist, or should that be done by the producer over here? Now we went with the design to eat the complexity with our producing data product. And we used some small tricks to enable that. One of that was that we standardized our schema representations across those two different catalogs we have in play here. So in our Iceberg catalog, we produced our tables at dataproduct.schema.model, and then by definition we produce these tables on dataproduct.schema.model inside of Snowflake. That helped the integration to work rather smoothly, and is a good trick for that. Now, what was also announced at the Coalesce then was that dbt would like to enable this as a standard workflow inside of dbt. So the whole setup we custom built here around how do we manage this is now being taken into the DBT ecosystem to say, how can DBT enable this? And since then, we have had some conversation with the DBT team where they have been presenting some of their design drafts for how they want to achieve this. And some of the things that they had taken up, that was actually the design around how do we manage this complexity. It should actually be managed by the producer to be responsible for exposing the data to other platforms. Now, to me, this is a very promising direction because that means that a DBT project that was previously only running in one compute platform must then be able to connect to different compute platforms and execute code in 2 different environments. I don't know where this is going to end up, but I think it's a very exciting future that we are looking at. So that was challenge number 1. And to get to challenge number 2, we need to go back. We need to go back and consider, how do we scale the mesh? How do we provide a great data foundation with these building blocks that we have? So far, it's been technology focused, but how do we actually organize the data that we are dealing with? So a lot of this is work in progress. We are figuring out how do we want to attack this problem right now. So some of the things we have been trying to do right now is to divide the whole, how do we understand our data landscape? And what are the different components we want to have to understand and make use of this data? So we are dividing it into a couple of different spaces here. So we have the actual data being represented over here in the physical space, where we have data being produced and consumed. We have the actual operational systems where the data is produced first time, interacting with different business processes. And then we have our consolidation sphere, where we are then building central data models, foundational data models that will be responsible for exposing this data to the wider ecosystem, where it will then be used for different analytical use cases down here. Then one of the things that we are working on getting to apply to all of this to understand our data across this whole life cycle is we are working with this information architecture space, where we are starting to design and figure out how do we want to work with information modeling? How do we want to actually model our data? So when we are talking about some data up here in our CRM system, that is represented by a logical model here that can follow that through its life cycle into the analytical data platform, and then eventually down into the consuming space for that data. And then we want to attach the different data governance policies and all of that to the information models, so we can get visibility on what do we need to be in control across the full data lifecycle. And then finally, we want to organize all of this around different enterprise data domains, where we will organize all of this content. So we have been building last year in one team. We have been building out how can we start to attack this foundational data models area. And then we have been building in a couple of different domains. So we have been building information in these 5 domains here in this space here. And then we have been looking at how do we then make that data available and consumable for different data products downstream of that. So the information flow is, of course, a little bit complex. But essentially what we are trying to do is to centralize information about, for example, customers in the commercial domain here, whether that is from ERP or CRM, and then make that available to the different data products where we then want to consume that. So we centrally manage and build out information about that in these domains, and then we consume that where we need that information to drive business value. Now, the next level of this is then what are then the entities that we want to organize this content around. So here is a number of the different entities that we have been starting to model in this space. Let's not go into detail on that, but just show then how does that then link to the information space. So in the information space, we want to have information about the different entities at play when we are talking, for example, about service contract. How are these related? What are the business processes they are a part of? And what are the key pieces of information we need to be in control of? And then when we then link that all together, then we will have these entities that are naturally going across different domains being linked to the information model where they are necessary. Now, this is a journey that we are on. We are not done. We are just starting out. So we have a lot of questions that we want to try to figure out how do we actually achieve scale for this. As I said, we started out as one team building these all of these consolidated data models in different domains. Now we want to scale that up by splitting the responsibility for these domains into different teams. So some of the open questions: how do we empower different teams to build and release independently? When I in one team have my park asset, and then in another domain I have my sales document, and then I want to consume that in a third team, in a third data product, that then represents this relationship we have up here between what turbines are actually covered by which service contract. So I can get this information about, well, which turbines do I need to provide what service level to. So how do I scale this up across different teams? How do I empower teams to work and release on their own? How do we deal with these cross-domain dependencies? How do I actually have requirements flowing from my analytical use cases back to the different domains where we need to produce the right data in the first place to solve these domains? How do we work with information modeling? How do we both mature how we work with information modeling and ownership of that, and then do that incrementally, do that in steps, because we are not going to hit perfect in one go. And then finally, as we have a lot of complexity here on how we are dealing with the information, how can we help our consumers by abstracting all of that away and making the consumption simple and easy? Those are some of the challenges that we are that we don't yet know the answers to. We are working down that path and figuring out how do we use some of the technology building blocks that we have to enable that. Yeah, that's what I had. I wrote questions, but I can't hear anyone. But I.
So any questions for Ulrik, then I can repeat them so you can hear it through this laptop here. Yeah, please.
What was the Iceberg catalog you're using?
Which Iceberg catalog are you using, Ulrik?
So this one here. So the Iceberg catalog on the Spark side here, this is a Unity catalog where there is a REST API to read the Iceberg information.
Other questions to Ulrik?
What are the team size working on?
How large is your team? What is the size of your team working on this? Is the question, Ulrik?
So if I go over here, this one here. So the team size around each of these domains, I think we are, I would say a squad. So it's around 10 people per team. and it's not necessarily one team per domain. I think in my team we have 3 domains that we are dealing with, but the team size is around 10 persons per team.
More questions?
So what do you do around discoverability? Do you have a catalog, a business catalog, data catalog, something like that?
Yes, I could actually hear that also. So that's one of the things that we are maturing, I would say, right now. And where we need to find the right role of the different pieces that we are talking about. Because in the information model, the open question is, do we want an information model? Do I want information about each of the individual data sets and what that contains? Most likely not, because this is about where I abstract away the business information. So right now we have actually just sunset one catalog and introduced another one where we are introducing the data products, where we are making them available, where people can see what is in the data products of each individual, data product essentially. And then it's to be decided what else we want to have in that data catalog. Yeah, we are on Informatica now, data catalog.
Thank you. More questions? Yeah, Martin, this time. Out loud.
Yeah, a question about the streaming transformation. About that, you said you use DBT for batch transformations.
Not able to hear anything.
The question is, how about streaming transformations? You use DBT for batch transformation. How about streaming real-time transformations? Are you doing this? And if yes, how are you doing it?
I'm not too deep in what we are doing there. I know that we are using Confluent. I don't know how much transformations we are applying when we receive it. I know that we have done some setups over here around using dynamic tables in Snowflake together with the Confluent Kafka connectors to some of the different source systems. But yeah, so I don't know how much transformations we are doing on the streaming side there, but I know we are doing something over here on near real time, not as much as you could do over here in the actual streaming world.
So you get the last question now. I'm looking at the clock.
So what about federated computational governance? What if you're talking data mesh, what are you looking at on that front?
Could you hear that, Ulrik?
Almost, but I need you to repeat it.
Federated data governance across the mesh. How are you doing this? That's the question.
I think. I think that to be found out question. We don't know yet how we will achieve that. So if you have valuable learnings, then I'm all for hearing about them and experience in that area.
Thank you very much. I had a question myself. I will leave that to later. It's time's up now. So thank you very much, Ulrik, for this presentation with very, very short notice. It's very, very much appreciated. Thank you very much.
Hope you could use it.